With a too hot and neutral feed, it is imperative that the homeowner understand the need for a proper grounding system. In a properly grounded electrical system, the grounded conductor, often called the neutral, provides a low impedance path for electrical current to flow back to the source. The grounding system also includes grounding electrodes, such as ground rods, that dissipate the current into the earth. In the described situation, with only a too hot and neutral feed, there is no effective grounded conductor or complete grounding system in place. This means that any electrical fault or surge could create a dangerous electrical potential difference between the garage and the house. Connecting phone lines, television cables, or plumbing between the two locations could provide a pathway for this stray electrical potential to travel, creating a significant shock hazard. To ensure a safe electrical environment, a proper grounding system must be installed between the garage and the house. This should include firstly running a grounding conductor, typically a 4/0 copper conductor, from the main electrical panel in the garage to the main electrical panel in the house. Secondly, installing grounding rods at both the garage and the house, ensuring they are properly bonded to the grounding conductor. Thirdly, bonding all metal components between the garage and the house together, including any plumbing pipes, metal conduits, and electrical boxes. The grounding conductor is often referred to as the equipment grounding conductor or EGC. It serves as a low impedance path for fault current to return to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to quickly trip and clear the fault. The size of the grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. Refer to the National Electrical Code, or NEC, Table 250.122 for guidance on sizing equipment grounding conductors. Grounding rods, also known as grounding electrodes, provide a connection to the earth. They help to dissipate fault current into the ground, reducing the risk of electric shock. The NEC requires a minimum of 8 feet of contact with the earth for grounding electrodes. Common types of grounding electrodes include ground rods, ground plates, and underground metallic water pipes. Bonding is the process of connecting all metal components together to create an electrically continuous path. This ensures that all metal parts are at the same electrical potential, minimizing the risk of shock. Bonding is required for metal water pipes, gas pipes, metal conduits, and metal enclosures. Bonding jumpers are used to connect these metal components together. The size of the bonding jumpers is determined by the size of the equipment grounding conductor. Refer to NEC Table 250.102 for guidance on sizing bonding jumpers. It is also crucial to ensure that the grounding electrode system is properly installed and maintained. This includes ensuring that the grounding rods are driven deep enough into the earth, that the connections are tight and corrosion resistant, and that the grounding conductors are protected from physical damage. Regular inspections of the grounding system are recommended to identify any potential problems. In addition to the grounding system, ground fault circuit interrupters, or GFCIs, provide an additional layer of protection against electric shock. GFCIs are designed to detect ground faults, which occur when current leaks to ground. When a ground fault is detected, the GFCI quickly trips, interrupting the flow of electricity and preventing electric shock. GFCIs are required in many locations, including bathrooms, kitchens, and outdoor areas. Understanding the principles of grounding and bonding is essential for ensuring electrical safety. By following the recommendations outlined in the NEC and implementing a proper grounding system, the risk of electric shock can be significantly reduced. Always consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with applicable codes and regulations. Neglecting proper grounding can lead to serious consequences, including electrical shocks, fires, and equipment damage. The grounding system is a critical component of the electrical system, and it should be treated with the utmost care and attention. Proper grounding and bonding is not just a matter of code compliance, it is a matter of safety. It is essential to protect yourself, your family, and your property from the hazards of electricity. By taking the time to understand and implement a proper grounding system, you can create a safer electrical environment for everyone. The information provided is for general guidance only, and it should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with applicable codes and regulations. Remember, electricity can be dangerous, and it should always be treated with respect. If you are not comfortable working with electricity, it is best to leave it to the professionals.